Hello everyone, my name is Arnold Tyven Madamombe, and I am excited to be here today to present my work on ATM interface and library management system. Before diving into the details, I would like to share a little bit about myself. Recently, I was honored to be accepted as a Java development intern at Oasis Infobyte, which is a fantastic opportunity for me to apply my programming skills in a real-world environment. This internship allows me to work with modern Java technologies, understand professional software development practices, and gain hands-on experience in building applications that solve real problems. I am thrilled to bring the knowledge and skills I am gaining from this experience into my current projects, and I hope that through today's presentation, I can give you an insight into both the technical work I have done and the learning journey I am on. So during my internship at Oasis Infobyte, I was presented with 5 different project tasks to explore and develop. So as you can see, this is the task list that I got from Oasis Infobyte. And this task list consists of 5 tasks. That is online reservation system. Task number 2, number guessing game. Task number 3, ATM interface. Task number 4, online examination system. Task number 5, digital library management system. Each of these projects offered unique challenges and learning opportunities ranging from simple console-based applications to more complex database-driven systems. So after carefully reviewing the requirements and considering the skills I wanted to strengthen, I decided to focus on 2 key tasks. That is the ATM interface and the library management system. So I selected these projects because they allowed me to dive deeper into core Java development and apply advanced concepts such as object-oriented programming, OOP, file and database handling, that is using MySQL, Postgres, H2, Docker, and Spring Boot architecture. So the ATM interface gave me the chance to simulate real-world banking operations like deposits, as you can see here, deposits, withdrawals, and account management in a secure layered application. Meanwhile, the library management system provides valuable experience in building a CRUD-based system application. CRUD, that is create, read, update, delete, with the proper data storage, user authentication, and transaction tracking. So by working on these 2 projects, I not only improved my Java coding skills, but also learned how to design applications with the scalability, maintainability, and the user experience in mind. So most importantly, these tasks reflected real-world systems that people use every day, making the learning process both practical and meaningful. So I'm going to present how I wrote the code for these 2 tasks in 5 seconds. Yeah, so once again, I'm going to present my Spring Boot project. This is an ATM interface that I created using the Spring Boot framework. So this project was completed during my internship at Oasis Infobyte. where I worked as a Java development intern. The main goal of this project was to understand how real-world Java applications are structured, particularly with the Spring Boot, REST APIs, database integration, and object-oriented programming. It is a console-based and web-ready application which allows users to perform ATM operations and manage library resources. So this system, it allows users to log in securely, manage accounts, perform deposits and withdrawals, and also view transactions and maintain a library of users and resources. The architecture follows a layered approach with entities, DTOs, mappers, repositories, services, and controllers. Each layer has a clear responsibility, making an application easy to maintain, extend, and debugging. So, for example, you can see here there is a package named model. In this package consists of the entity classes. An entity class represents database tables. For example, let's open the account. As you can see, this account class. There are annotations here. This annotation tells Spring Boot that this class is an entity class. And also, instead of generating setters, getters, or constructor and a default constructor, I used annotations. This annotation is setter for setters, it getter for getters, at all ARG constructors for constructors, at no ARG constructors for default constructor, which is needed by the JPA entity class. And also here we have the table name. And so here the account entity contains an ID. That's the primary key, the ID. And also the balance, data type picked as mal, the balance, and a reference to the app user. You can see that there is also the reference to the transaction. So the app user stores username, as you can see here. We have the app user. The app user stores the username, password, and transaction tracks, deposit withdrawals, and transfers. We also have an Hibernate, which maps these classes to database tables automatically. We have other entities include app user and transaction with the relationships defined inside using the annotations like min to one, for example here, one to min, and also the min to one annotations. So from there, I created the TTO package. Inside the TTO package, there are also TTO classes. As you can see here, a TTO, it stands for data transfer objects. Help us send only the necessary information between the layers. For instance, account TTO contains only the account number and balance. It also hides sensitive information like user passwords. That's why you can see here we don't have user passwords is the information which is very sensitive. So it's like the TTO, it exposes the information that we want the client to access. Then if we have the sensitive information that we don't want the client to access, then we don't have to include it here in the TTO. So this TTO, it's a record. It's a record class. Why I made it a record class? It saved me from using those annotation of getters and setters and constructors. So by just using, for example, let me demonstrate here by clicking here, right click, new Java, new Java. I selected the record here. So instead of using the Java class, the interface, I selected the record. So that's why, as you can see, there are no annotations for getters and setters. Here, even below, there are no constructors and getters. I didn't even generate, because once you have a record, everything is inbuilt. It's inside. So here we also have the transaction TTO, which contains only the transaction type and amount, because here we created the enums for the transaction type. That is it a transfer? Is it a transfer? Where is the enum? The enum package. Okay, all right. Yeah. So the transaction types are being shown here, whether it's deposit, withdraw, transfer in, and also transfer out. From there, we also have the mapper package. From the mapper package, we also have the mapper class. Mappers are utilities classes that converts entities to TTOs and vice versa. For example, this account mapper. From this account mapper, as you can see, account mapper, right? As you can see from this account mapper, when a user checks their balance, the account entity is converted to account TTO and sent to the client. As you can see here, and sent to the client. Similarly, we have user mapper and transaction mapper to convert this entity. So for example, here we are mapping the entity to TTO, and vice versa. As you can see below here, we are also mapping the account TTO to entity. Right. We also have a package for repository. Inside the package for repository, there are these interface classes. So repository, they handle communication with the database using Spring Data JPA. As you can see, Spring Data JPA. We created an account repository. As you can see here, the app user repository and the transaction repository. So let's go back to account repository. As you can see, this allows us to find all accounts of a user without writing the SQL. Methods like save, find account by number, like methods like save and delete are built in, and we can add customs. For example, I added my custom query, find account by number. But all the CRUD functions, for example, create, read, delete, they are all inside here. Right, so from there, we created a package for services. This is the service package, and also we have the service class. Service class, the service contains all the business logic here. That's where the business logic is. For example, the account service here handles the deposits, account service handles here, as you can see here, it handles the deposits, and also it handles the withdrawals. Then from there, we also have the transaction service. It tracks all the deposits. The transaction, it tracks all, as you can see here, it tracks all the deposits, withdrawals, and transfers. Service keep controllers lightweight by separating request handling from business logic. Then we also have the controller package here. The responsibility for controllers are the entry points. The controllers are the entry points for client request. Account controllers, for example, here we have the account controllers, handles the login and transaction controller. The account controller, it handles the account operations. Then transaction controller here handles the transactions. So the controller receives the requests, calls the service controller here, they receive the request, then it calls the service here, and it calls the service. The service converts the results to DTO. After converting the results to DTO, and returns it to the client. This keeps controller clean and focus. Then we also have a package for exceptions. So these are my customs exceptions here that I created. We also have the customs exceptions. I implemented custom exceptions like insufficient balance, daily limit exceeded, account number not found, account already exists. So, for example, here, on the insufficient, this is the insufficient balance exception. So, if a user tries to withdraw money more than the balance, this exception is thrown. This exception is thrown, and the client receives a clear error message. So, for example, here, insufficient. Let's go to account service. As you can see, account service. You can see here, the exception has been thrown here. When someone tries to withdraw money, yet there is insufficient balance, and this exception has been thrown here from this customs exception. So, if the user tries to withdraw money more than the balance, this exception is thrown, and the client receives a clear message. This is a clear message that you are having here: insufficient funds. This ensures the system is robust and prevents invalid operations. Right, we also have the security part. As you can see here, the security configuration, and here we also have from the TTO, we have the login request. Here, from the login request, we have the service class with the authentication service class. So the application uses Spring Security by default. Spring generates a temporary password for development. We replaced it with authentication service, as you can see here, for user authentication, which validates username and passwords, as you can see from the login request here, that here there's a usernames or an email and the passwords. So this ensures only authorized users can access their accounts or perform transactions. So to summarize the workflow here, the user sends a login request. Yeah, sends a login request. Then it sends to auth controller. Then from auth controller to the auth service, then it validates the credentials. So after logging in, the account operation go through the account controller. Here we have the account controller. Then from account controller to the account service, then from the account service to the account repository, then from the account repository to the account mapper, then it responds. So transactions are recorded by transaction services. Transactions are recorded by that's where the business logic for transaction is here. So the transaction services are being recorded here and converted to DTOs. They are being converted to DTOs for the client. So this layered architecture ensures modularity, maintainability, and a clean separation of concerns. So in conclusion, what I can say is that this project demonstrates a complete Spring Boot layered architecture using entities, DTOs, mappers, repository services, controllers, customs exceptions here, and secure authentication. It helped me understand real-world Java application design and reinforced best practice for maintainable, secure, and scalable system. Thank you all for watching my presentation. I hope you found it informative. You can access the complete project, including all tasks, on my GitHub repository at the provided link below. Feel free to explore the code and give feedback. Thank you once again for your time.